Hello, in this video of the month we're reviewing this recent article, Intraoperative Trypan Blue Central Landmark and its use in capsulotomy and capsulorhexis centration by Pupil Centration, Richard Packard and David Mordaunt, with examples in manual capsulorhexis and laser capsulotomy. When we use an optimized Trypan Blue solution like CAPSULBLUE, it takes about 30 seconds to really get a nice dye and to see the landmark develop. If we use generic, it'll take longer, take several minutes, but it's present. We see it after washout, and then it gets further enhanced with a little bit more time. And once the OVD backfill is done, you can see a very nice pronounced landmark. This just shows the different anterior segment Trypan Blue solutions, rate of staining and resultant intensity. So both of these images are for 60 seconds of stain. You can see very clearly that the Trypan Blue, CAPSULBLUE, is more intense, and it also stains much faster because of the optimized formulation. So of course you don't have to leave it for 60 seconds. You can leave it for about 5 seconds and get an equivalent stain. The landmark is visible at around 20 to 30 seconds, so somewhere in this range it starts to develop, and really it is very strongly developed by 60 seconds. Here we see some representative examples of the Trypan landmark in cataract surgery. We can see there's a high correlation with the coaxial Purkinje reflex, and if we measure this, we can see that it's a very high correlation indeed, with about 0.1 millimeters distance between the Purkinje image and the landmark center. And for an anatomical system, this is pretty interesting. So to summarize, the Trypan central landmark is present in over 98% of patients. It's circular, it's about 2 to 4 millimeters in diameter, but it does vary from patient to patient. There does not seem to be any notable trends as yet, but bilaterally it is the same. In younger patients, the stain is lighter, and to really get an enhanced landmark, we suggest using longer dye exposure times to enhance the visibility. We do observe a correlation with coaxial Purkinje image and potentially IOL centration, and this is the genesis for the study, which we discussed in the rest of the video. In this JCRS paper, two major things. Number one is the first identification of the Trypan central landmark, and number two is then a study to look at centration of capsulotomy relative to the IOL. So 180 eye prospective consecutive case series is conducted with 3 arms: pupil centration, Trypan capsular landmark centration, and then coaxial Purkinje image centration. And the endpoint is to look at the decentration measurement of the capsulotomy from the IOL, and also compare the capsulotomy center to the Zeiss IOL master referenced via the Callisto eye and the video screen that's presented. This is what we'd all like to see in our cataract surgeries, where we have the IOL that's symmetrically supported 360 degrees around its complete circumference, providing symmetrical support for the IOL through not only the surgery but beyond. And these are the corresponding capsulotomy images with capsule laser centered on the Trypan landmark. But we're going to explore Trypan landmark, Purkinje image, and pupil center. The fundamental question is, why is capsulotomy centration important? The goal for capsulotomy location is to be centered on the resultant IOL position, so that the IOL has symmetric coverage and support from the capsule. This is critical in reducing uncertainty in the effective lens position, as uncertainty in effective lens position leads to increased uncertainty in the visual acuity outcomes. Incomplete IOL coverage by the capsulotomy can lead to early onset PCO, asymmetric fibrosis, which leads to IOL decentration and tilt. In this example, we see that the capsulotomy has been incomplete, and then the resultant rim rides up against the IOL, and we can see the early onset fibrosis occurring here. This will not only affect clarity, which can be dealt with a YAG, but the effective lens position is not going to be ideal either. So in the study we have three arms. Pupil-centered capsulotomies. So these capsulotomies were all centered on the dilated pupil. In group 2, the capsulotomies are all centered on the Tripan landmark. And then in group 3, we focus and center on the coaxial Purkinje images. So on to the results. For group 1, pupil centration, this yields asymmetric IOL coverage. And we can see it's kind of random in the direction of which the asymmetry occurs. So it's not deliberately inferior or nasal, it's very random in its directionality. And on patients like this, where we have the center of the IOL, the visual axis about here, we can see that this may affect and induce some dysphotopsias. So not ideal by any means. As we look at the decentration of the capsulotomies relative to their IOLs, we see a large spread with an average of 0.3 millimeters. And I think the real concern is going to be the patients which are out here at 0.3 and 0.4 millimeters and greater. This is our potential of unhappy patients with either dysphotopsias or incomplete IOL coverage. For group 2, centering on the Tripan capsular landmark yields symmetric IOL coverage, quite remarkably so. We do see some slight variations, of course. And this is the measurement of the decentration of the landmark relative to the IOL center, and we can see it significantly improved over the pupil centration at 0.15 millimeters. We do see a spread, so there are some patients that have slightly larger, but we have no patients in the 0.3 millimeters and greater zone here. So this actually is very promising. Likewise for group 3, where the centration is on the coaxial Purkinje reflex, there is symmetric IOL coverage. The graph is very similar to that of the Tripan landmark group, where we see a spread, but we do see no patients with greater than 0.3 decentration. And we can imagine that that provides a very good approach. If we do a statistical analysis looking at superiority and inferiority, we see that group 1 has a large spread in its standard deviation or confidence interval for the decentration of the capsulotomies to the IOLs, and we can see group 2 and group 3 are above the average, and quite convincingly so, and their confidence intervals are clearly superior to that of the pupil centration. So very clearly the Tripan landmark centration and the coaxial Purkinje image centration are equivalent, but are superior to pupil centration. So although it looks very nice on the table, for the phase 1, I think that we really need to evaluate this more closely and consider an alternative method than pupil centration. So if we look at IOL master data imported into Occlusto Eye and reference matched, we get the central landmark, which is denoted by the crosses here, and the circles. And the circles denote 5 millimeters, which is the capsulotomy size, and 6 millimeters kind of representing where the IOL may well be located. And what we can see here is that for the pupil-centered, sometimes it's relatively good for its prediction, and this is a very symmetric eye. But as we kind of move forward, we see that there are asymmetries that develop, and this is what we actually see. We actually do see something very similar to this, where the capsulotomy is right on the edge of this IOL optic body, denoted by the 6 millimeter optic ring there. Moving on to group 2, we see there's a high correlation between the IOL master data for the visual axis and the center of the Tripan landmark. And again, these kind of denote the 5mm diameter and then the optical body of the IOL, showing and indicating that this would be a good location for the capsulotomy centered on the IOL. And for group 3, similarly, we see the same behavior where the Purkinje image is exactly aligned with the central visual axis, and again, predicting if a capsulotomy is created there, it will be very symmetric to the IOL optic body, which is what we indeed see. So a few tips and tricks that we found by conducting this study. First, we're very familiar with using Purkinje reflexes in cornea surgery. When we're working with cataract surgery, we obviously aren't looking for the first and second. We're looking either for the coaxial Purkinje image or the third Purkinje image. So just wanted to bring this up as an example. So in image A, we have a very nicely placed coaxial Purkinje image, and we don't see a ghosting or a third Purkinje image here. It's kind of centered behind the first and second. And in this example, the lower one down here, we see that there is a ghosting there and there is that third Purkinje image in the background. What I do want to draw your attention to, which is quite interesting, is that if the first and second are centered, which are the dominant Purkinje images, are centered on the Tripan landmark, you're really getting the best of both worlds. You're getting the coaxial Purkinje image and you're getting the Tripan landmark. So it's a very good check and balance that you really are on the visual axis. Now, we may not be able to use patient fixation and the Purkinje images if we have opaque cataracts or if there's local anesthesia of the eye. But the Tripan landmark is always available. So for manual capsulorhexis, we're going to center our capsulotomy on the Tripan landmark. And we're just going to ignore the Callisto eye currently. And you can see we get a nice circular capsulotomy, and then we can see how it is located. So if we apply these overlays, the green overlay being the IOL optical body, the white overlay being the CCC rhexis rim, and the blue is the Callisto eye limbal centered capsulotomy prediction, we can see first the Callisto eye would actually have missed in this instance, and we would have incomplete IOL coverage. And importantly, using the Tripan landmark, we see a very nice predictor of where the capsulotomy should have been. And the slight deviation here is because the capsulotomy, although it was very circular, was just not quite circular in this region. So a great result and should be very good outcomes. Now, we have a few capsulotomy videos here just showing the consistency of capsule laser on the Tripan landmark. We often see the Purkinje images are actually not that applicable here, and we can see there's tilt in the eye with the third image back there. And again, the Purkinje image is not coaxial, but we're using the Tripan landmark in this, and we're getting very nice centered capsulotomies on that Tripan landmark. We'll just go through a few more cases of this just to show the consistency, and then we'll jump to compare it with the IOL implantation and see how it predicts from there. Let's just go from there. So we have 24 eyes conducted over 2 OR lists, and we can see the centration and how it was conducted with respect to the landmark. These are consecutive cases. You can see objectively here we're slightly decentered, and we are pretty damn centered on the IOL here, but maybe it is a little wider over here. Likewise, these are all very centered, and we see great centration on the resultant IOLs. And again, consistently as we went through the day, basically we have very good centration. Sometimes there's a slight narrowing of the gap, meaning there's a slight adherence or some fibrosis that may be present there that then is dealt with. But the resultant capsulotomies are all very strong. As we go through here, And again, consistency, great results. We'd all be happy with this. This is a 7mm optic body from Human Optics, so a larger IOL. We are looking at actually increasing our capsulotomy size with this type of IOL, probably to 6mm or so, just to see potential of what that can do with dysphotopsia. Different topic. And again, just looking at centration, 360-degree overlap, symmetric outcomes. In all cases, very happy patients, very good results. We just see consistency throughout. So with true centration, achieved either with a coaxial Purkinje image or the Tripan landmark, we can achieve very nice centration of the capsulotomy. This coupled with laser precision with respect to diameter and circularity, we get excellent 360-degree coverage that's symmetric. And it's not only true in premium surgery where we're dealing with, say, a refractive lens exchange, but also in more complex cases. For example, pseudoexfoliation patients and also white cataracts or intermescent cataracts. In conclusion, the Tripan central landmark is present in over 98% of patients. It is circular with a diameter of 2 to 4 millimeters. It is observed to correlate with the coaxial Purkinje image and aid in IOL centration. The study concluded that centering on the coaxial Purkinje image and the Tripan central landmark are equivalent techniques and both are superior to pupil centration. It is obvious that in mature white cataracts, non-fixating patients, and anesthetized patients, the Tripan central landmark is the best technique. And to go further, centration on the Tripan central landmark provides the most practical approach to achieving symmetric 360-degree circumferential overlap of the IOL. It's never been stated this way, but what we're really seeing is that the visual axis is identified by the coaxial Purkinje image, Zeiss Callisto I when it's reference matched to IOL master data, and the Tripan central landmark. And capsulorhexis or capsulotomy centration diameter are critical for optimal effective lens position and minimizing early onset PCR.